Yeah, hi, good morning. Yeah, today I am discussing topic related to background services in ASP.NET Core. The main use cases for this service is in our application for file processing. File processing means suppose we are uploading the file which is more than I can say 10 MB or 500 MB or 1 GB. So end user from UI is uploading the file. So through API he is uploading, but there is a lot of time consumed by the API to process this file. Assume 500 MB file. To process this file, API will take lot of time, so user will not wait to for the response. So what we are doing here is we are using background services. Whenever request come from the UI will upload the file to the through API, but API will not process that file. Here API, what processing means, here API is doing validation and what are the data available in this file is in exact format or not, like that normally processing happen. But now here API is doing just checking what is file limit, file size, whether this file size limit is less than our required limit. Next we are checking API is checking what is the file type, whether the file which is uploaded by the end user is either PDF, whatever we require, those file he is uploading or not. That's it, we are checking here. Then finally we are sending the response to the UI. Like we observe in uploading the PDF books, it is taking wait for 2 minutes. Internally processing is happening, but for end user response is given. Your file is processing. From end user point of view, he think that he is uploaded a file, but whereas previously without background services, end user doesn't get the response, end user will stuck synchronously, this thread is stuck. So in those scenarios we are using the background services. So I will briefly explain the workflow, how large file is processing happening. First, from the end user point of view, this is UI screen, and here this is API. This API is responsible to uploading the file, and we have worker service. In future classes we will discuss the scalability of worker services. Is there we need to deploy multiple worker services, or how auto scaling, these things we will discuss architectural from architectural point of view, where this worker service will came, like that. Now just for file uploading API, I will explaining the basic workflow. We have one UI from the end user will upload the file from this UI, and we have API. This API just check the validation whether this file is a PDF, XML, whatever we set in app that setting file. Based on the configuration, API will check and validate the limit. Then finally API, what it is doing, we have file stream system.io. With that stream classes, we just insert that file in particular location. That's it. And finally sending the response to the UI. Now we need now next responsibility taken by the API is uploading the data to the worker service. What data? Just now we get a API uploaded by some end user, and I store this file in this particular path. You need to process that path. Understood? Now worker service getting the details from the API, that API is saying that I upload this file here. What you have to do, you just take that file and process that file. The processing logic, whether they are uploading in database, any data manipulation, all things taken responsible by the worker services. Okay, how we are sending the data from API to the worker services? Now in our architecture we are maintaining the queue. In this, from this queue, API uploading the data, message data, that location of the file, what you have to do this file, this data inserted in this queue, and let me say this is a channel instead of queue. So worker services retrieve this queue from this channel and processing based on the requirement. Finally, we need to update this result, like PDF is processed, you can able to download, like that we need to update to the UI. This part how we are doing through SignalR. Understood now? So this is the main requirement in our application. So file processing through background services. So conclusion here is we have the main components are one UI to the end user, next one API to just accepting the request from the UI, next one we have worker service to do the processing of the file, and we need one channel. Through this channel API will communicate to the worker, and finally we need SignalR. Through SignalR we are worker service responded to the UI. Okay, now here this is the file system. Through this file system, end user is not end user, API is uploading here. Okay, this is our architecture for file uploading. So this is our requirement. Now I will go deeply what are the things in ASP.NET Core provided to implement this architecture. First we will start from iHosted services. We have built-in interfaces. One is iHost object, iHosted service object, then background service, then we'll discuss worker service. Okay, now first I will start with iHosted service. Let us assume that before that, first I will start with iHosted service. So iHosted service, a responsibility of the iHosted service is to run the processing with separate task. Means it is run in another task in background. So let us take, we have application contain multiple services. These services run by the application thread only, but iHosted service run by separate thread, or I can say this thread from thread pool only, or separate task. We no need to bother who is running, whether thread or task. Internally thread is running, but our thread or thread pool thread, by default thread pool thread it is running. Okay, so to get this functionality other than applications, we need to run separately. To get this functionality we have iHosted service. Okay, this is built in. I will describe the implementation of the host object, but basic workflow is this is our application. There are multiple services, service 1, service 2, service 3, etc. These services are run by the application only, means either sequentially, parallelly, but application thread only. But I need to run one service which is background other than application. So processing of the application is happening here, and this thread is background thread is happening. To implement these functionality we require a hosted service. Okay, so just I will explain what are the built-in interface. What are the methods of this built-in interface? We have start async. So this is the method we writing our logic, background logic. I will describe who is calling this method in future, but this is actually this method is called by host object. Okay, I will describe later. I am concentrating on I hosted services. We have start async method. Whatever logic inside the start async method run by the thread, that is background thread, not application thread. We need to cancel this thread. We are using stop async. Okay, conclusion: I hosted service run by the separate background thread, and our business logic will contain inside the start async method, and in order to cancel that running we are using the stop async. We'll explain laterly how the implementation. And next thing I need to discuss is background tasks that are expected to run. This is application task, this is background task. So we know the lifetime of the application, and what is the lifetime of this background task. So background task lifetime also your application lifetime only. This background task expected to run for the lifetime of your application. Okay, but it will start before running the application. First background service run, and immediately it is written by the task. Means what happens? Immediately it is written. Suppose start async method is there, like our event loop is there. Event loop internally encapsulated multiple tasks. It will not process all task functionalities. Just it will process and return and give the processing. If business file stream logic is there in this task, give to the thread pool. But this event loop processing of this task is complete, then after that pick up another task. Means just for invoking purpose, event loop is extracting what are the task events which need to process. If large processing task is there, it will give assigned to the thread pool. Like in the same manner here start async method is there. Here how they are writing this, just instead of passing, returning the task. Okay, then after I hosted service processing, then pick up the application services like Kestrel. Here now Kestrel server, first it is processing I hosted service. It is not taking that much of time. Immediately start async method, immediately it is returning the task. This task, this is the task written by start async method. Okay, this task is processed by separate thread from thread pool, but the thread actually invoking will return task. Okay, this is the main. If actually we have start async method is there, here we need to return task, and this task contain the whatever background logic. But if we here instead of returning the task, if we write the code like that is avoid here, that means start async will not return the task, it is waiting. If this start async start waiting, then application by default become blocked. Why I am saying like that is, suppose I have application thread. This thread what it is doing, first invoke the I hosted service. After invoking the I hosted service, application contain Kestrel service to handle the incoming request. Then application will need to start running the Kestrel service. But here itself the thread is blocked. Throw away. No, throw away thread is not blocked, but it will do the processing for other functionalities. But here thread is blocked in a manner of control flow. This flow is blocked here itself. Now the control flow will not process to here. Then Kestrel service. So what I am saying that these services are actually designed to run continuous, not parallel. During continuously running, if any hosted service will block the thread, then next step processing will be blocked. So that's why finally there are final last service, Kestrel service, that is it is handling the request. So here it is blocked. So what I am saying, the statement is calling await in the iHosted service method will block your application from starting until the method completes. This can be useful in some cases, but it is not a desired behavior, because this thread which is starting the application will need to invoke the Kestrel server. Kestrel server's responsibility to handle the incoming request. Okay. So to avoid the mistaken, developer make this mistake calling the await method and without returning the task. These are the two mistakes if developer do, then application will break. One is not returning task. Second is calling await method. If application which is inherited if any services which is inherited by a hosted service not returning the task and not calling the await calling the await will make your application will be blocked until this long running process completed. So long running process will not run in background. Our core responsibility of the iHosted service to run in background. To run in background, we need to return the task, and next is we need not call the await method. Okay, that's it. For that purpose, developer making the mistakes, to avoid that mistake, ASP.NET Core given the one hosted service, that is background service, which is implemented by the iHosted service. This background service implemented is and the iHosted service. Now we'll discuss this background service in later class.